Welcome to the AI for Career Success video overview by Curt Robbins, where we help you get smarter than your competition. This episode reviews an informative article from this show's producer, information architect Curt Robbins, entitled Chain of Thought Prompting Enhancing AI Interactions, that was published on LinkedIn. Now, his analysis is based on a really foundational research paper from the Google Research Brain team, which you see here. We're going to break down their key findings on how to unlock more advanced reasoning in AI. So here's our roadmap. We'll start with the problem, what we're calling the AI reasoning gap. Then we'll explore the solution, a chain of thought. From there, we'll look at the proof, first in arithmetic and then in common sense reasoning. And finally, we'll discuss why this all seems to be an emergent property of scale. All right, let's dive into section 1, the AI reasoning gap. This is where we explore a pretty fundamental challenge facing even the most advanced AI today. This really brings us to the core question the researchers were trying to tackle. Why is it that these incredibly powerful models, which can do so much, often stumble when you give them a problem that requires simple, step-by-step logic? You see, large language models are fantastic at a lot of things, like translating languages or analyzing sentiment. But for a while now, their performance on reasoning tasks has been a known limitation. They often get tripped up by problems that need sequential steps to solve. Think of things like math word problems. And this brings us to the solution the researchers came up with, an innovative prompting method they call chain of thought. Now, to really appreciate this new method, we first have to understand the old one, standard prompting. This is where you just show the model a few examples of a question and a direct answer. It's a very straightforward input-to-output pattern. Chain of thought prompting, on the other hand, is a completely different approach. Instead of just the question and the final answer, you show the model the intermediate steps, the reasoning that leads to the conclusion. You're basically teaching it how to think through the problem. And you can see the difference so clearly right here. On the left, with standard prompting, you're just asking the AI to make a leap from the question to the answer. But on the right, chain of thought lays out the entire logical path, guiding the model step by step to the right conclusion. Okay, so the theory sounds solid, right? But does it actually hold up in practice? The researchers decided to put it to the test, and they started with arithmetic reasoning, which has always been a tough spot for these models. This chart just illustrates the results beautifully. That bottom line, the flat one, shows what happens with standard prompting. Even as the models get bigger, their math skills don't really improve. But look at the top line. That's chain of thought. As the model size increases, the performance improves dramatically. This technique is unlocking potential that was just sitting there, dormant. And the hard numbers really tell the story. On a key math benchmark, Google's Palm model using just chain of thought managed 58% accuracy, which already beat the old record. But here's where it gets really interesting. When they combined it with another technique called self-consistency, the accuracy just shot up to an impressive 74%. So the results with math were undeniable. The next logical question was, can this technique work beyond just numbers? What happens when you apply it to the much more ambiguous world of common sense reasoning? To figure this out, they tested it across a whole range of benchmarks designed to evaluate different kinds of everyday logic, things like common sense QA, strategy QA, and even specialized topics like understanding dates or sports. And the most impressive results, the real standout, came from the sports understanding test. With chain of thought, the Palm model achieved a remarkable 95% accuracy. To put that into perspective, that score actually surpassed an unaided human sports enthusiast who scored 84% on the same questions. Okay, this all leads us to the final and perhaps the most fascinating piece of the puzzle, the relationship between the size of the model and its ability to perform this kind of advanced reasoning. The key takeaway here is that this ability isn't something that just gets a little better as the model gets bigger. The researchers describe it as an emergent property. A good analogy is water turning into ice. It doesn't just get a little more frozen. At a certain point, it undergoes a complete phase shift. And similarly, the ability for chain of thought reasoning just appears once the model hits a certain size. And they were even able to pinpoint that threshold. It seems the benefits of chain of thought prompting only really kick in once a language model reaches a scale of about 100 billion parameters. Before that point, the technique doesn't offer much of an advantage at all. In their conclusion, the researchers expressed this hope that by showing how to unlock these reasoning abilities, their work will inspire even more research into using language to solve complex problems. And that really leaves us with a final, profound question. This work represents a shift away from just getting quick answers from an AI. The bigger question for all of us is, what new and more complex problems can we solve by teaching AI not just to answer, but to actually think?
Thank you for watching. This is where we teach you AI and help you get smarter than your competition.
If you like these videos, please consider using the QR code that was on screen at the beginning of the video to buy us a coffee. And of course, please subscribe to the AI for Career Success YouTube channel. Liking, commenting, and sharing really helps us reach a wider audience.